Welcome back to the channel, everybody. My name is Tech. In today's video, I want to show you this really cool tool I've been using a lot recently called Rekognition within AWS. I'm going to show you how you can set it up and utilize it within a .NET application. So to start off then, what is Rekognition? Well, Rekognition is a service that AWS provides, and it has loads of different capabilities. So it can do label detection, so it can do things like these where you give it a picture and you can detect loads of labels. So here you can see it's detected a car, a person, a skateboard. It also has image properties, which kind of piggybacks off the label detection, and we can see here it's given us various different colors here around this picture, and you can see if we change to the car, you can see all the colors change to match that car's picture, which is really nice. So the facial analysis then, what that basically does is it takes a photo and it's going to let us know whether there is a person within that photo. So this is really cool. If you're maybe taking an ID photo, you want to make sure there is actually a person there. It's not someone kind of hiding out the way, or they've put the hand up to the camera, or whatever it is. You want to make sure there's actually a person, a real person in that photo. This is the tool you'd use. On the other hand of that, you've then got face comparison. Now, this is a tool that it provides that actually lets us compare if the person that we have a record of is actually the person that is there right now. So let's say, for instance, we use the detect faces to actually capture an ID photo of a person, let's say myself. We store that in S3, and now we come back maybe a day or so later, and we want to see if we are that same person. We would use the face comparison, we would give it the original photo, and would take a photo now, and we send them both to Rekognition, compare faces, and it would give us a result, whether that is a match with confidence, similarity scores, everything like that. It's a really nice feature. There is a celebrity recognition feature as well. We won't really touch on that much in this video, but it can detect all kind of celebrities if that's your use case. There is also then a text in image feature, which actually is really useful. So if you have, in this case actually, a picture of a car and you want to make sure that you want to pull a registration from that picture or anything like that, this is a really cool endpoint as well. And then lastly, what we'll touch on is the PPE detection endpoint, which, as it says, you can detect whether or not a person has PPE on their hands, on their face, on their head, whether that's a hard hat, whatever it is. That all works within Rekognition. So how does all this work then within C# and within .NET? So you can see here, I've got a just a .NET Core Web API with 5 endpoints. You can see we've got the face detection, we've got the face comparison, we have the label detection, text detection, and PPE detection. And all of these go to a particular service. So we have a face detection service, a comparison service, a detection service, an image read service, and a detection service again. You notice at the top here, I have this builder services add Amazon, because this is linking to my other Amazon project that I have up here. So if we go ahead and look into this, we'll just find all of the dependency injection. So you can see we're registering Amazon Rekognition, and then we're registering all of our custom services that we're going to run through now in this video. You will need to make sure your IAM user is configured within your local machine. If you haven't done that and you want to know how to do that, click the link in the description, and I have a video on that already that shows you how to configure and set up your IAM user with the AWS command line interface. So if we start off with the face detection service, you can see all we have is a very simple public class. It has dependency injection through Amazon Rekognition, and we inherit of the face detection service interface that we've created just for our dependency injection. We then have a function in here called detect face that takes in a bucket name and also a key. So how we're using this within this current architecture is we're going to be storing all of the images within S3, and then we're going to pass Rekognition a bucket name and also a key for that object. You don't have to use S3, you can use image bytes. However, I just think it's best practice to use S3, and then you also have a log then as well of all the historic pictures that you've sent to Rekognition. It just makes things a lot neater. So you can see we start off then, we just do a new request, we do a new detect faces request, and we pass in an image. You can see here we're passing in a S3 object. Again, if we wasn't, we could be using the bytes, as I mentioned, which you can do up to 5 megabytes, but in this tutorial, we're just going to be focusing on S3. So you can see then we pass in a bucket, which is the bucket name from that parameter, and we also pass in a name, which is the key. We're going to get all attributes from this detect face, so you can whitelist particular attributes if you want them to. We're just going to bring back them all, and then we simply return that response. So if we look in Postman then, and we go to the face detection endpoint, and we can see here we are passing in a bucket of Tech tutorials, and we're just going to use that same Jeff Bezos portrait that we got from AWS. If we send that, we can see the raw JSON that we'll get back. So you can see it's given us an age range of highs. So the highs, it might be 48. Lower 48. Does this person have a beard in the photo? It's 95% confident, and it's confident that that value is false. So this person, Jeff Bezos, in this picture, doesn't have a beard. You can see there it's also given us some bounding boxes. So you saw on AWS where it kind of circled the person's head and all the different objects. That's all these bounding boxes. So if you want to do something like that in your own application, it gives you all that data as well. Again, it gives you a confidence score, and then we can all see all the various different emotions and all the different attributes that it returns. So again, if you want to just detect a face, we can see right here as well that we do have a face. If we uploaded a picture that doesn't have a face, we would obviously get a response back, and you can handle that in your application. Say, well, hang on, you've put your hand up against the camera, or you just haven't shown your picture, or whatever it is, you can do that within your code. So the next one then is going to be the face compare endpoint. So let's go ahead and we can look at that. So again, we go to the face comparison service, and it's pretty much going to be the same in every single service. They're very similar. The AWS SDK is really good for things like this. So we can see we just have a face comparison service that inherits our face comparison service interface. We're passing in the AWS Rekognition interface from the AWS SDK. And then we have a function in here called compare faces that returns a compare faces response. And that takes in a bucket name, a source photo, and the target photo. So the source photo is going to be what we're going to be taking right now, and the target photo is going to be what's actually stored of that person that we're going to compare against. It doesn't really matter which way you get them because you're going to compare them anyway, but that's how it works. So you can see then we have a request. So we're going to do a new compare faces request. We're going to get the source image, which is a new image. And again, we just pass it in exactly the same before as an S3 object. Again, if you wanted to use bytes, you could use bytes, but we're just going to do S3 in this case. And then you have your target image, which is again another S3 photo, which I just have in S3. If I quickly show you those, it's just a simple bucket, and I just have all of these keys in here like so. So you'd obviously handle that programmatically in your code. You take the photo, store it in S3, and then you'd move on to this section right here. We then have a similarity threshold. At the minute I have this set to 90. You can make this higher or lower. So if you want to kind of make sure AWS is 95% confident, you could change it to 95. We're just going to leave this at 90. I found this is the sweet spot. It is very, very accurate. So you could probably go higher, 95, 96, 97. Most of the use cases I've found in a real world environment, most of them average around 98 to 100%. So it's very accurate, even in low light conditions. It's a really powerful tool. So if we do this then, so let's go ahead and call this endpoint. So we go back to Postman and we have the face compare endpoint here. We can see we're calling the face comparison endpoint. We're going to pass in the bucket Tech tutorials. Our source photo is a photo I got ChatGPT to generate of just a random person. And then our target photo is going to be Jeff Bezos. Now, obviously, because these are two completely different people, this is obviously going to fail. So let's go ahead and look what that looks like. So let's hit send. And we can see the face matches object is actually, well, it's actually an array, but you can see it doesn't have a value because there was no real matches detected in this photo because obviously there was two completely different people. But we can see in here unmatched faces, and then we'll get a confidence of whether this is a face or not. And we can see all of the different emotions and again, all of the different points on that picture. So if we go ahead and we put Jeff Bezos in both of them, so let's say Jeff Bezos is there and also there. Now this time our unmatched faces is actually empty because we actually do have a face match, which is really good. And if we scroll up, we can see face matches, we have a value and it's detected a face. We can see we've got the bounding box there. It's 99.9% confident. As I said, it's a really great high score. Landmarks, we've got all the different breakpoints of the eyes and the mouths and the nose. And then the similarity, which is actually what we look for in that code where we've got this set to 90, is actually 100%. So this is, well, it's the same photo, so that would make sense. So again, this is a really cool feature within AWS. You don't need to learn about machine learning or anything like that. Just literally pass the two photos to Rekognition and it will return us whether that was a match or a non-match. Next up then, we're going to have the label detection service. Now there's two aspects of the label detection service. You can use the label detection service, which is built into AWS, or you can do custom labels. Now I'm not going to touch on custom labels in this video. If you want to learn more about that, let me know and I'll do a video on it. But custom labels is where you can train your own model to look for particular things. However, every time I've needed to use labels, AWS already has that out of the box. So it could be PPE, it could be whether someone has earbuds in, it could be whether there's a phone in the photo or glasses or whatever it is. Out of the box, the detect labels works pretty well. It's only if you have a really edge case where you'd want to train your own model, but you can do that within AWS as well. So for the detect labels then, we're going to head and we're going to do very similar to the other ones. We're going to pass in a detect labels request. We're going to pass in our S3 object. You can also pass in how many labels you want AWS to return. So we're just going to pass that in as a parameter. And then we're going to pass in a minimum confidence rating, which we're just going to put set to 75 for this instance. And then we're going to send that request off to AWS. So let's have a look at what this looks like then in AWS, in our endpoint even. So we can see we're calling the API label detection, we're passing in a bucket of JLTech tutorials, and then we're going to be passing in a key and also the S3 bucket. So in this case, we're using a picture of a skateboard. So if we go ahead and hit send, we can see it's detected loads of various different things. So you can see it's detected buildings and architecture. Well, these are the characters. You can see the parents here. It's detected that this is a city, it's a road, it's an urban city or an urban road. We can see there is a human here. It's detected a person. It's also detected automobiles in this photo, and you can see it's also returning all of those boarding boxes that we saw within the actual AWS interface. It's returning all of that information here within your C#, so then you can do whatever you need to do with that inside your application, which is really nice. Next up then, we're just going to have the text image read service. So again, this is where we can read text from an image. So if that's a picture of a car and you want to read the registration plate, this is a perfect example to do that. So as you can see, it's a very simple function. We just have a function called read text from image that has a parameter of a bucket and a key. Nothing similar or nothing different, sorry, from the other instances that we had. And you can see we're passing in a new detect text request. We're passing in our S3 object and we're sending that to the Rekognition client and we return the response. So within AWS, let's go ahead and look what that looks like. So we're going to pass in a picture of a green car. And again, we're passing that in with a bucket and also the key. And if we send that, we can get the response back. So you can see in this picture, it's detected comb. That's probably from the shop window, which we're not really going to worry about that. But you can see here, it has actually detected the registration plate of that green car, so that we could then go and add that into our system, whether that's a vehicle lookup or, you know, which car is driven into our business today or into our car park or whatever it is. This is a really great tool to use. Lastly then, we have the PPE endpoint, so your personal protection. If you want to make sure if someone's, you know, kind of signing into your construction site, you want to make sure they have a hard hat, a high vis, whether that's safety gloves, safety goggles, whatever it is, the PPE detection endpoint does exactly that, and it works really, really good. You can see from a code perspective, it's very similar to our other endpoints. We literally just have a detect PPE function with a parameter of a bucket and also a parameter of a key. And then we send in that as a detect protective equipment request off to the AWS SDK Rekognition client. We pass in our S3 object and we return the response that we get back. So let's go ahead and look at Postman. We're going to obviously pass in the person from AWS that's wearing all that PPE, and let's go ahead and send that request. As you can see, we're getting all of the equipment detection come back as an array. So we can see here body parts. So this is a body part of a face, and the equipment that is detected is a face cover. If we scroll down, we can see left hand has a face cover. So we can see this person has PPE correctly wearing on his left hand and also his face. We can see hand cover for the right hand, which the value is true and it's 99.8% confident. We can see the head, we have a head cover, so that's a hard hat. And then we got some other metadata down below as well. So that's, again, really cool. It removes all that human input. You know, someone's coming on site and you want to make sure they've got all the PPE. It's a really nice method to do that. So there you go, everyone. That's how you use AWS Rekognition inside your .NET application. If you do want to download this solution and have a play around yourself, feel free. The link to download from my GitHub repository will be in the description below. However, with that said, if you did enjoy this video or if you did learn something from it, please do drop a like rating or subscribe to the channel, and I will see you all next time.